The above sequence diagram illustrates the interactions and data flow within a Kubernetes cluster when a user requests the creation of a new pod. It captures the communication between the main components of the cluster, including the user, API server, etcd, scheduler, controller manager, and Kubelet. Here's an explanation of each step. 1. User to API server. Create pod request. The user initiates the process by sending a request to the API server to create a new pod. This request typically comes through a command line tool like kubectl or another interface. 2. API server to etcd. Write new pod state. The API server processes the request and writes the desired state, i.e., the new pod definition, to etcd, which serves as the key value store for the cluster's state. This ensures the information about the new pod is stored persistently. 3. etcd to API server. Acknowledge state write. etcd acknowledges the state change, confirming to the API server that the new pod's information has been successfully stored. 4. API server to scheduler. New pod to schedule. Once the pod's desired state is stored, the API server informs the scheduler about the new pod that needs to be scheduled onto a worker node. The scheduler is responsible for finding the most suitable node based on resource availability and other constraints. 5. Scheduler to API server. Node selection. The scheduler selects an appropriate node where the pod can be deployed and reports this decision back to the API server. 6. API server to controller manager. Update desired state. The API server updates the controller manager with the scheduling decision. The controller manager ensures that the current state of the cluster matches the desired state by initiating actions, like creating or deleting pods. 7. Controller manager to API server. Acknowledge state update. The controller manager acknowledges that the desired state update has been processed and is being managed to maintain the cluster's state. 8. API server to Kubelet. Start pod on selected node. The API server sends an instruction to the Kubelet on the selected worker node to start the pod. The Kubelet is the agent responsible for managing the pod lifecycle on the node. 9. Kubelet to API server. Pod is running. Once the Kubelet successfully starts the pod, it sends a confirmation back to the API server, indicating that the pod is now running. Summary. This diagram illustrates how Kubernetes components collaborate to handle the creation and deployment of a pod. It shows the step-by-step process, starting from a user request, through storing state changes in etcd, to scheduling and finally running the pod on a worker node. The flow ensures that the control plane components, like the API server, scheduler, and controller manager, maintain the desired state of the cluster, while worker nodes, through Kubelet, execute the workloads.